let's level up.
Yeah, we can see it.
Thanks, Kai. Always have my back. I appreciate you. All right, let's level up. All right. So the problem with that, oh, there it is. There's polls. Okay. All right, we're at level 1, and I am launching the poll, hopefully. I will give you guys 1 minute to answer these 2 questions. The temperature of an object is related to kinetic energy of its molecules, true or false? Kinetic energy decreases as the speed of molecules increase. And if I'm looking, I have about 30 of you, if I don't count Miss Krista, myself. Oh, and Miss Angelica, so about 30.
And Dalton just joined.
Awesome. So you're answering that question.
Like my background.
Awesome. I'm going to give it 3, 2, 1.
Oh, no.
Awesome. I'm going to end the poll. I'm sharing results. You guys should see that on your screen now. Miss Dolls, I see you. So you're the one that needs to give me thumbs up, thumbs down. Okay. So the temperature of an object is related to the kinetic energy of its molecules. This is true. The temperature of an object is related to the kinetic energy. So if the temperature and kinetic energy are high, they're related, right? Or low. That doesn't mean that the kinetic energy gives the temperature. It just means that they have a relationship, right? The next one, kinetic energy decreases as the speed of molecules increase. This is false. This is false, friends. I don't know what Miss Dawes is doing, but she's messing me up. Okay, so increase, increase, decrease, decrease. So if kinetic energy increases, the molecules are increased. If kinetic energy decreases, then the molecules are decreased. Okay, so very, very good job, guys. Let's just review molecules really quick. Remember, molecules move and change speed all the time. They can be going fast or they can be going slow. Okay, if it's hot, then the temperature is a measurement of that kinetic energy. If we feel hot, we can assume there's a lot of kinetic energy moving, right? When we increase molecules, we increase kinetic energy. Okay, so that's what we know about molecules. All right, level 2 questions. Answer these level 2 questions while I read what gauge, let me see. Kinetic energy means movement. Yep. Now I understand why Miss Krista was laughing. Okay. Yes.
Kinetic energy is movement, and movement transfers to friction. Friction is creating heat.
Yes. So
and the heat of the molecules makes the molecules go faster, and the more kinetic energy.
I think I accidentally put the wrong thing.
Okay. So Gage, you are right. In this thinking in this lesson, we're only worried about the kinetic energy that moves the molecules, whether molecules move fast or slow, and the temperature about it. The friction part is where we kind of move off of this unit, but absolutely, you definitely understand it. Oh, these ones are closer in answer. I'm going to give you guys 3 more seconds, 2 more seconds, 1 more second. I'm going to end. I'm sharing results. So warmer objects transfer
Energy.
Energy, friends. It's energy. Warmer objects transfer energy to cooler objects. Not temperature. Remember we read that article about how
Temperature?
not energy, right? They're
You said temperature.
they're related, but not the same. Okay. And will Mrs. Burnfin's hot coffee make the air around her warmer? Now, if you were in a morning session where I held my session at home, this would have been easier to remember because I did that in the morning, right? Will it make the air around me warmer? Yes or no? Most of you said yes, but that's incorrect. Incorrect, friends. The answer is no. If I have coffee in my hands, there's really not enough molecules in a cup of coffee to heat the air around me. And that's because the air in my entire room has way more molecules than the air in my cup, right? But if I were to open my oven, that would be a different story because there's a lot of molecules in that oven, and a lot of molecules in the kitchen, and kind of like,
Can I say something?
that's where you would say, man, Mom, the kitchen is hot today. And probably not because their food is good, but mostly because the oven is hot. Yes, Kai, you want to add to it?
It's because the coffee cup or whatever you have that's warm is so small, it doesn't have enough, so it evaporates. And then since your house or the school is so big, the coldness goes into the coffee cup instead of the coffee cup comes out. And when the oven's more bigger than the coffee cup, and it can contain more heat. So then that makes the air around you hot.
Awesome. Yes.
And another could I add something to that?
Absolutely, Gage.
Your coffee cup can only have so much heat. So can your oven, but your oven makes heat. The coffee cup is hot. It cannot make it any hotter. It can keep it hot, but it cannot make itself hotter.
Hot, unless it had something else that added that heat, right? Excellent. Making sure that we have the confidence to answer these questions. Remember, if it's your first thought, that's the thought you go with. All right. Go ahead and use your annotation tools. I want you to annotate, friends. They should be there, correct? And I want you to tell me about the transfer of energy. So we're definitely going to put this in a very visual way. Using your annotation tools, do you think the milk is getting hotter or colder? And do you think the coffee is getting hotter or colder with the coffee getting the milk put into it? I'm sorry, that was my voice. So is the milk getting hotter or colder? And then is the coffee hotter or colder? After you put some milk into it. Okay, I'm going to put a pause in 3, 2, 1. Stop. Oh, I said stop. Excellent. Okay. From my understanding, most of you think that the milk is getting colder, but then the coffee is also getting colder. Okay, remember the relationship between hot and cold. The milk, oh, I see 4 or 5 students not listening. We should not be touching our annotation tools. Awesome. Okay, if cold milk, oh. Okay, I'm gonna shut my annotation off because you guys can't follow instructions.
I listened.
Okay, so with the transfer of energy, if the cold milk is put into the hot coffee, the milk is going to be hotter than it was to begin with because of the hot molecules that transfer to the cold molecules, which is that cold milk, right? Warmer objects transfer energy to colder objects, okay? That would mean that if the milk got hotter, what got colder? If the milk goes hot,
The coffee.
the coffee goes cold. Gage, was that you?
Yes.
you explain why that is in this image that we can see?
The heat transfers from the coffee to the milk, so it will equalize.
Perfect. Yes, when we're talking about the transfer of energy, warmer objects transfer their heat or energy.
Like when you have toast in the morning, you put the butter on it, the butter is cold, but after a little bit it's hot, so it melts because the toast is hot.
Excellent.
Can I add to that?
Example. Yeah, Kylie, can you hold on a minute? Lexi, I saw you raise your hand. Did you want to add?
I have a question.
Yeah, I would love to answer your question.
But hot can only transfer to hot.
So what are you talking in temperature or molecules?
In temperature.
Okay, so in temperature, if something is hot, it has a lot of molecules, correct? Would we agree?
Mrs. Burnfin?
Hold on, Gage, I am answering a student's question. So Lexi, go ahead.
So how could the milk be getting hotter if it's cold?
Okay,
Because
perfect. So when we're looking at this picture here, we know that the coffee is hot, right? And the milk is cold. And when this relationship happens right here, it's mixing, correct? So hot and cold, could you agree, are mixing?
yeah.
Okay, so the molecules that the hot has, which is a lot of molecules that are moving, and the molecules that the cold have, which are not very many molecules moving very fast, are actually becoming more like one. And it's transferring energy, that kinetic energy. And when that kinetic energy, you see this movement going on right here, when that milk is dropped, right? That kinetic energy is then making the milk warmer. For example, I would not drink my coffee and taste cold coffee after I put cold milk into it. I would taste warm coffee. Did that help you answer your question? Perfect. Kylie, I would love to know what you have to donate to this conversation that could help your classmates.
So when when I was at my aunt's house, my nephew was my cousin was taking a bath, and my other cousin had to put hot water into the bathtub, but when she got to the bathtub, the water got warmer, not more hot, so it got a little cold.
And that's because of the molecules in the air of the bathroom, right? Increasing. That's why a lot of people shut the doors to the bathroom or put shower doors instead of curtains, because that helps that heat stay in, that temperature, those molecules, right? Those are all great examples. Kylie, with your shower example, Gage with your toast and butter example, these are great. All I can think about is coffee because that's just who I am. But
Did you read my last message?
I did, yeah, and that's really helpful for others who are reading. That's perfect. Thank you. Okay, so this just helps us understand really quickly. I'm just throwing it out there about our supporting concept. When milk gets hotter and coffee gets colder, energy is not created and destroyed. The energy is transferring. So when the milk gets hotter, the coffee is colder, right? And when we put more heat, then the coffee will get hotter, right? But that transfer of energy is never destroyed. It just goes into my body and gets warm and creates more issues with energy in my body, right? But the milk and the coffee concept shows that energy isn't created or destroyed. All that energy is still there, just some of the molecules are with the milk now and some of the molecules are with the coffee. Okay? So hopefully that helped. Kai, you have something else to say?
Yeah, so when you add, say you're making hot cocoa and it's a little too hot, and you add some ice to it, and then it gets more cold, and because you added the ice.
Fabulous. Absolutely. Absolutely. You are 100% correct. All right, level 3. Let's see if we can do level 3, understanding of energy. I'm launching the poll for 1 minute. These are your questions. Changes in temperature are affected by the number of molecules in a system. Temperature is a measure of Temperature is a measure of, I'll read it one more time. Changes in temperature are affected by the number of molecules in a system. True or false? Temperature is a measure of about 15 more seconds.
Be careful, guys. She has another screen open where she's watching all the poll numbers. Choose wisely.
She's a witch.
Choose wisely.
Yes, I can.
There are no mistakes,
There.
saith Master Uguay.
Okay. So changes in temperature are affected by the number of molecules in a system, and temperature is a measure of, I'm ending the poll and I'm sharing your results. As a class, you said changes in temperature are affected by the number of molecules in the system. Absolutely correct. It is the number of molecules that affect the temperature. Remember, we tend to think that energy equals temperature. That's not true. It's the molecules that have a relationship with the energy to create the temperature, okay? Temperature is a measurement of kinetic energy. It shows us how much kinetic energy is the molecules are creating. Remember, molecules can be slow or fast, but when we relate temperature, it has to relate to the measurement of kinetic energy, which is the energy of the movement of the molecules. Everything's connected, right? All right, I'm going to stop sharing.
If anybody read my last message, you'll understand what she just said.
Yeah, well, and we should all understand this is our end of unit assessment, right? All right, energy. More molecules equal more kinetic energy equal higher temp. This is a way to look at it. The more the molecules you have, the more kinetic energy you can create, the higher temps you have. You can have the same amount of molecules, but if they don't have kinetic energy, you're going to have something cold, right? And we explained this in the fact of, if I opened an oven, my kitchen would feel warm. But if I drink a cup of coffee in my kitchen doesn't feel any different, right? And that's because all those molecules are moving with faster energy. Because my oven's probably on 350 degrees every single day, and my cup of coffee is probably only like 60 or 70 degrees. Okay, one more time, we're going to try the annotation tool properly. One use. You take your annotation tool and you circle one Bitmoji of Mrs. Burnfin. Which molecules are moving faster? Is it the coffee or the water? Which molecules are moving faster?
The coffee.
Is it the coffee or the water? Awesome. I appreciate you guys setting expectations this time. Awesome. 3, 2, 1. Yes, you guys are all understanding the supporting concept, which is that molecules of hotter objects move faster. Okay, that was a supporting concept we worked on all unit long. Very good job. Okay, I'm going to clear your annotations. No one else should be annotating. Awesome. Thank you. All right, I'm going to stop share. I'm just going to look in the chat really quickly just to make sure I didn't miss anyone's question. Okay.